So we're moving on to the next step. So we're now going to be in the ocean. So everybody take a deep breath and just kind of sit by the ocean. Okay? Because we are going to dive into the mysteries of the ocean. As you travel deeper, the water gets colder, the light fades, and marine life adapts in amazing ways. So joining us is Aaron Lemonston. He is the environmental educator, and Chimnaye Kenkipati, education operations specialist. Both of them are from Georgia Aquarium, and they are here to help us explore the ocean's layers and the incredible creatures that thrive in its depth. Aaron and Chimnaya, welcome and happy STEM Day to you.
Hello, happy STEM Day to everybody. So, my name is Aaron.
And I'm Chinmai.
And I'm an environmental educator at Georgia Aquarium.
And I'm an education operations specialist at Georgia Aquarium.
All right, so we're going to go ahead and dive right in, no pun intended. Give us 1 second because we do have a presentation for you guys pulled up for you. Alrighty, can everybody see that presentation nice and clearly?
Yes.
Baby, is that presentation coming up nice
Yes.
and clear?
Yes, I can see it.
Excellent. All right, guys. So we're going to go ahead and just jump right in and talking about what's going on in the ocean. We wanted to share with you guys some really cool facts about some of the different zones of the ocean, the different animals that we can find all the way down there. Let's go ahead and take a look. But first, a little bit of context as to what we are talking about. So there's one global ocean that exists, but humans and scientists have kind of divided it up geographically and given it different names. So we've got about 5 oceans total. So there's the Pacific Ocean, which stretches between Asia, Australia, and North America and South America. In between the Americas and Africa and Europe, we have the Atlantic Ocean. Kind of nestled in between Africa, Asia, and Australia, we have the Indian Ocean. We have the Southern Ocean, which just stretches all around the continent of Antarctica at the South Pole. And then finally, up at the North Pole, we have the Arctic Ocean. Now, the ocean covers about 71% of the Earth, and it actually contains 97% of the water on Earth. The remaining 3%, so all of our lakes and rivers, streams, estuaries, that only makes up 3% of the water on this planet. So we actually don't have that much drinking water compared to the amount of water that is actually on the planet. Now, one thing that's really important to note is the difference between an ocean and a sea. A lot of people use these terms interchangeably, but they actually do refer to 2 different things. So seas are going to be generally smaller than oceans, and they're usually either partially surrounded by land, whereas oceans are vast and not enclosed by land. So that's a very key difference to understand because we're focusing on oceans and not seas today. Now, the oceans actually can be split into 5 different zones. And it's around 4 to 5 actually, depending on where you are in the world. So, for example, at the top, our top layer is going to be our epipelagic zone, also known as our sunlight zone. Now, this is where you're going to find about 90% of ocean life. And we get lots of sunlight hitting the zone, which allows for lots of plankton growth. There's 2 types of plankton that are really important to know. We have our phytoplankton. Phytoplankton is going to be our plant plankton, and then zooplankton, which is our animal plankton. Now, the phytoplankton is going to be a very important food source for basically everything else in the ocean because all of those ecosystems start off with that phytoplankton using it as that primary producer. It's producing its own energy. All the other organisms are consumers, so they're going to be feeding on that phytoplankton or eating animals that eat that phytoplankton. The other kind of plankton that's important to know is our zooplankton. So zooplankton is our animal plankton. Both these kinds are equally important because that zooplankton is usually going to be that very first thing feeding on that phytoplankton with lots of other animals feeding on that. And then next layer down, we have our mesopelagic zone. That's also known as our twilight zone. Now, this zone gets the name because it's pretty dark down there, but you still get enough sunlight to be able to tell day and nighttime. And you get animals that have different adaptations. A lot of them have large eyes to be able to process as little light as they're getting. Now, the next layer down is going to be our midnight zone. This is where we actually start getting no light at all. And it's very cold down there, about 4 degrees Celsius. And this is where we start getting lots of extreme pressure and darkness and cold. And this is where you start getting animals that have to adapt to those very specific environmental conditions. So they're getting some really interesting body plans as a result of it. Then we're going to go even further down to our abyssopelagic zone, also known as the abyss. Now, most areas of the ocean are going to stop at this zone. For most parts, this one's going to be the deepest one. And this is where you have, again, really intense pressure from all that water weighing down on these animals, no light at all, and very, very, very cold temperatures. So they have to adapt to those really extreme conditions. Now, that fifth zone is this one listed at the bottom of our slide. That's our hadal pelagic zone, also known as the hadal zone. Now, this zone is interesting because it only appears in the trenches. So think of places like the Mariana Trench or the Puerto Rico Trench, those areas. We're going to find that hadal zone. And this is one of the most intense ecosystems on the planet. A lot of animals have to adapt to these really extreme pressures, no light at all, extreme darkness, extreme cold down there. So they're having to really, really adjust to it. So without further ado, let's take a look at some of these zones and highlight some creatures that are living in here. We're going to start up at the top of our ocean with our epipelagic zone. And the species we're spotlighting today is going to be manta rays. We've actually got 3 manta rays here at Georgia Aquarium. So here's some fun fact about some of our guys. Manta rays are one of the largest ray species out there. A giant manta ray can have a wingspan of up to 20 feet wide, and they can reach weights of up to 3,080 pounds. Now, manta rays are also known as devil rays because they have an interesting adaptation. So if you look at this picture of the manta ray on the left-hand side, you'll see that it has a pair of fins. So we call those fins cephalic lobes. Now, the cephalic lobes can curl up and they can uncurl. And when they're uncurled like they are in that picture there, that manta ray is guiding plankton into its mouth for it to feed on. So it's going to be feeding on that phytoplankton and zooplankton. And when the manta ray is not feeding, those lobes can curl up. Now, it gets the nickname devil ray because when those lobes curl up, they kind of resemble horns. And so that's how they get that nickname devil ray. Now, one interesting adaptation that manta rays have been observed doing is that they've been observed actually jumping out of the water. And even here at Georgia Aquarium, R3 will sometimes jump out of the water each day. And there are a couple of different theories as to why they might do this. Some scientists believe this might be a social behavior. Maybe groups of manta rays are doing this to communicate with each other, or maybe it's a social dominance thing. Other scientists think they might be trying to escape a predator. And there's another group that thinks that maybe they're attempting to dislodge parasites, different organisms that are trying to attach to the manta ray, maybe trying to drink some of its blood, that kind of thing. And the manta ray is trying to dislodge them by breaching out of the water really quickly and then smacking down back into the water. Now, another interesting feature about manta rays is that they possess 18 rows of teeth, but because they are a filter feeder feeding on really tiny microscopic organisms, they're not really needing those teeth for anything. They're kind of a vestigial trait, so teeth are slowly disappearing over thousands of years. Now, another interesting thing about manta rays is that they are what's called ovoviviparous. So there's a couple different ways that animals can have their offspring. There's oviparity, where an animal is just straight up laying eggs. Think like how a chicken might lay eggs and that kind of thing. Then there's viviparity, which is going to be just live birth, kind of like how a human gives birth to a baby. And then there's ovoviviparity. Now, ovoviviparity works a little bit differently. That's when the animal does have eggs, but instead of hatching outside the mom's body, the eggs hatch inside the mom's body, and then the mother gives birth. So that's what manta rays do to give birth to their young. Now, manta rays are pretty cool animals, but unfortunately, they do face a couple of really big conservation threats. One of their natural predators is large sharks. That's normal predation that has to happen to maintain a healthy ecosystem. But the other big threat that manta rays face is, unfortunately, humans. A lot of animals are unfortunately fished around the world specifically because people believe that different parts of their body can be used for medicinal purposes. Some cultures believe that eating parts of an animal is kind of a status symbol. Unfortunately, this has really been depleting manta ray populations. Manta rays, for starters, have a gestation period of about 2 years, so they're pregnant for about 2 years before giving birth, and they only give birth to about 1 or 2 pups at a time. So they're not introducing more manta rays into the ecosystem at a fast rate, just due to the way their natural reproductive processes work. So when humans go in and fish them and they get entangled in fishing gear by accident even, we lose manta rays at a faster rate than what's being contributed to the environment. So unfortunately, these guys are an endangered species. The good news is that Georgia Aquarium is doing a pretty good effort in studying them. So we're trying to track manta rays and figure out where they're going out in the wild and figure out what they're up to, because sometimes animals migrate different areas and we're not sure what's going on over there because they'll dive down really, really deep. So we're tracking manta rays to help figure out what's going on. In addition to that, we are also designing new tracking devices, and our manta rays are helping us with that by being test subjects for us to make sure that these new types of tracking devices attach them properly and can even safely detach from the animal. So manta rays are going to be a good example of some of these epipelagic zone animals. And one thing that's really cool is that we've actually got a little video clip of you guys showing some more manta rays feeding. You can see that they've got their cephalic lobes uncurled and they're guiding that plankton directly into the mouths. Now, one thing that you'll notice in this video is that these mantas in this video, they've each got different color patterns. It turns out mantas will actually have their own unique color patterns, and we can tell them apart individually this way. In fact, this works for even the ones that we have at Georgia Aquarium. So for example, our biggest female Tallulah, she's going to be the darkest one and have the darkest pattern. Our smallest female is Nandi, and she's going to have the lightest pattern. And then our male, his name is Blue. He's got kind of a skull face on his belly. So that's how we can tell him apart. All right, so we've learned a little about manta rays, but now we're going to go ahead and do our next zone. And for our next zone, talk about the chamber nautilus, I'm going to let Chinmay take it away.
Hi, everybody. So the chamber nautilus is a really interesting animal. It has survived 5 great extinctions. So for a little bit of context, that means it's older than dinosaurs, which is pretty cool. The chamber nautilus grows chambers within its shell. So kind of like how a turtle is attached to its shell. A chamber nautilus will grow its shell and live in the outermost chamber. So you can see the its appendages poking out. So another cool thing about the chamber nautilus is that it has up to 90 arm-like appendages. They're not considered tentacles because they do not have any suckers or hooks, but most cephalopods, which is the category that nautiluses are in, have up to 7 to 8, like octopuses, squids, things like that. So the chamber nautilus is really cool for a lot of reasons and unique. Another thing that another adaptation that this animal has is that it is dark on top and lighter on the bottom. This is because of the zone that it's in the ocean. When predators are swimming over it, when they look down, they won't really be able to see it because the top of it is dark, so it blends in with the surroundings. So very cool form of camouflage. Another amazing thing about chamber nautiluses is that they have the ability to control their buoyancy. So buoyancy is essentially how they move around in the ocean. They are able to match with the pressure and the flow of the ocean around them by controlling the gas and the water within their shells. And you are going to see kind of how they float in the video that's upcoming. But real quickly, this video, this little clip right here, is going to show you guys how chamber nautiluses will retreat back into themselves and form a kind of armor. And that keeps other animals from, attacking their appendages or their eyes and things like that, which is also very cool. And here is a video where you can kind of see how they appear kind of weightless because they're able to control that buoyancy. They do that by using a tube called a siphuncle, which is very cool. And I'm going to give it back to Aaron.
Alrighty, guys. So we're going to go down to our next zone and talk about one of my favorite ocean animals, the giant isopod. So this looks kind of like some of the roly-polies in your backyard, right? That's because it's actually in the same family as those roly-polies in your backyard. It's just a lot bigger. So isopods are crustaceans. That means they're in the same family as lobsters, crabs, and shrimp. And I did say this one's a big one because it can grow to be 16 inches long. So that's about, just over a foot long in size. Now, the giant isopod is an example of what we call deep sea gigantism. This is when deep water animals grow to be very, very large. Now, scientists are actually currently unsure why deep sea gigantism occurs. One theory is that bigger animals use energy a lot more slowly, and you're down in the deep ocean, you're not guaranteed to find a meal for a long period of time. So maybe being really big slows down how much energy you burn, and you can kind of go without food for longer. Now, these guys can dwell pretty deep, about 1,600 feet. And what they're feeding on is that they're mostly scavengers. So they're kind of waiting for animals and plants that have completed their life cycle to sink down to the seafloor. And they're going to go ahead and scavenge on those and feed on them. Now, one really cool adaptation they have is that they have these swimming limbs kind of in the back half of their body that we call pleopods. Now, these pleopods can help them propel through the water, but they also do help them with respiration, so they help them breathe. What they do is that as the isopod is swimming through the water, the pleopods can kind of pass water over to the gills a lot more easily, and they help the giant isopod breathe down there. Now, even though these giant isopods are kind of living a pretty remote environment down that bathypelagic zone, that midnight zone, they do still face some conservation threats, well, the biggest one being plastic pollution. Plastic pollution, unfortunately, does reach down to the bottom of the ocean. We have even found evidence in the deepest parts of the ocean, such as the bottom of the Mariana Trench. And this is thought to be the biggest threat to these isopods because a lot of animals, including these deep water ones, can potentially mistake these items for food and ingest them. When that happens, those plastics can build up in their body, and sometimes plastic can leak toxins into an animal's body and cause it to get very, very sick and even eventually complete its own life cycle. So even though these deep water animals that we're talking about, live in pretty remote places, it goes to show that no place in the world is really untouched by what we're doing. And real quick, one thing I really want to show you guys is that these giant isopods, they might be a big old roly-poly, but they've still got a pretty good bite. So this video is taken a few years ago, but this was from a deep sea ROV, so a remote operated vehicle that was down at the bottom of the ocean that was observing some dogfish, which are a kind of shark, and some giant isopods. And here's that clip right now. So there's that shark swimming into focus, and there's it in the back corner, and then, yep, right there. If you watch that, if you look real close, you can see the isopod has actually latched onto the shark's face and is eating it. So because even the scavengers, they can defend themselves pretty well. So we're going to go ahead and move on to our next zone. And we're going to talk about the abyssopelagic zone. So I figured for our abyssopelagic animal, our abyss animal, it'd be fitting that we talk about the black sea devil. So this might actually be an animal that you've heard of recently, because this animal was actually in the news just a couple weeks ago. The black sea devil is a rare species of anglerfish that we know very little about. And this animal's actually been only filmed alive twice. Once in 2014, and then again just a couple of weeks ago. So that's why that big headline was citing this animal was such a big headline, because it was literally the second time we'd ever seen this animal alive. Now, it's thought that this animal feeds on small crustaceans that are kind of floating in the water. And like all anglerfish, they've got this lure on their head. That lure is essentially a modified fin, and it's bioluminescent. That means that it's making its own light. And so this lure kind of brings smaller animals in that are much more curious. And they're like, oh, hey, what is this? But it's actually a trap. See, the black sea devil is what we call an ambush predator. So they're using this lure to kind of bring their food to them. That way they can store their energy and sustain themselves off that stored energy for even weeks or even months at a time, just waiting for the next meal to come to them. Now, being all the way down the bottom of the ocean, unfortunately, that makes it pretty hard to find a mate as well. Now, the black sea devil that's in these pictures is a female, and we know this because she looks like this. Male anglerfish are quite a bit different. Male anglerfish are actually parasites on the female. So they're going to see that glowing lure as well, and they're going to see it, and they're going to swim up, and they're going to attach to the female. When the male attaches to the female, his mouth then becomes permanently fused to her body, so he can no longer swim away. He's no longer independently living. And eventually what's going to happen is that her blood vessels are going to start rerouting into his body. That way, some of the nutrients that she gets from her food are going to go to him to sustain him. And eventually he's going to lose his eyes, he's going to lose his gills, he's going to lose his fin. Which is going to be basically kind of a growth attached to her eventually, helping to fertilize her eggs and create the next generation of black sea devils. And we do see this on other anglerfish species, which is how we know that black sea devils do this. And sometimes these anglerfish have been found with up to 6 or even 8 males permanently fused to them. And then speaking of that video, in case no one has seen it yet, we actually do have a little bit of that clip to show you guys today. So you can see that black sea devil and why it was really important. All right, guys. So now that we've talked about the Black Sea Devil, we're going to keep on going even further down in the ocean. And we're going to switch gears, and I'm going to let Chinmay go ahead and talk to you guys about our next animal, the Hadal snailfish.
Hi again, everybody. All right. So the Hadal snailfish gets its name from the zone that it's in, which is the Hadal pelagic. The Hadal pelagic zone is actually named after the Greek god Hades. So that's where that name comes from. The Hadal snailfish is also known as the Mariana Hadal snailfish, which is named after the Mariana Trench. Now, the Hadal pelagic zone is usually found in trenches. So the base of the ocean floor is still considered in the abyssopelagic zone, which we just did. But the hadopelagic zone exists within trenches. And if any of you know anything about trenches, then the Mariana Trench is one of the most famous ones, which this little guy is named after. Some really cool adaptations that the Hadal snailfish has is that they do not have a swim bladder or other aerie organs. So what that means is a lot of animals like sharks and fish that live in the epipelagic zone have something called a swim bladder. And earlier, when we were talking about the chambered nautilus, we talked a little bit about buoyancy, which is how animals maintain their ability to stay afloat and control their ability to go down into depths or come back up. This animal, interestingly, the Hadal snailfish, does not have a swim bladder because of the pressure. Now, the pressure in the Hadal zone is immense. It is completely insane. It would be something close to like having 53 school buses stacked on top of you. And that would just be like a lower end for a number of school buses for the pressure that you would feel down there. So they can't really have any of those organs that have a lot of air or have a lot of room. So instead of a swim bladder, they make up for it with their gelatinous bodies. Their bodies are very malleable and gelatinous, and that allows them to control their buoyancy and swim without a swim bladder, which is very cool. And their coloring is pinkish and transparent. That helps them blend in because it's so dark in this zone that they just kind of disappear into it. A lot of colors don't reach down into this zone because the light waves are essentially eaten up by the darkness of the ocean. So these little guys have adapted to that. Some very cool facts about these guys are they do not have a lot of genes for vision, which means that they have adapted to not really need to be able to see in order to live, which seeing is pretty important for a lot of different animals. So it's very interesting that they have also adapted to that. They're also known as the deepest dwelling known vertebrates. We know that they live in these incredibly harsh conditions. It's very, very cold. The Hadal zone is actually only a couple of degrees away from freezing. So very, very, very cold. Very dark and a lot of pressure. What's also interesting about these guys is that there are over 300 different species. And most of them live in shallow areas like the epipelagic zone or kind of coastal zones. So it's really interesting that these guys found themselves in the deepest part of the ocean when the majority of them live in shallower waters. Not a lot of information is known about these guys because unfortunately when they are brought up to the surface, the pressure change causes them to melt, kind of explode a little bit because they're so used to being under so much pressure that when they're brought up, their bodies no longer can adapt to that, the lower pressure. We are able to study their bones when brought to the surface, and we have found that their bones are a little bit softer than our bones or a lot of bones from a lot of other animals. And we believe that that is also an adaptation for them to be living in such tremendous pressure. They also lay some of the biggest eggs of any fish, and they are, of course, a cold water fish, which is very cool. And in this next video, you'll be able to see them feeding on some ratfish. All right. And now we're going to learn about one of the most amazing migrations on Earth, the Deal vertical migration. Here's Aaron.
Let's see if we can get that switch over to, there we go. There we go. So let's go ahead and talk about Deal vertical migration. So Deal vertical migration is the biggest migration event that happens on Earth, and it actually happens every single day. So what this is that when we switch from day to night, a lot of these more bottom dwelling animals that we've been talking about in some of these lower zones actually are going to migrate up closer to that epipelagic zone. That's because there's a lot of plankton activity going on in that epipelagic zone, and these animals still depend on it. And you can see some of that happening in the video clip playing to the right-hand side of the slide. And these are a lot of deeper water fish that have migrated up to the surface, and they're going to be feeding on that plankton. Now, the reason why this is important is because this is helping to contribute to the carbon cycle. A lot of phytoplankton and zooplankton are storing carbon inside their bodies as part of that natural process of the phytoplankton go through photosynthesis and then the zooplankton feeding on them. And as carbon is kind of ingested into bigger and bigger organisms, it kind of accumulates. And when those organisms complete their life cycle, they sink back down to the seed floor. And so this helps a lot of not just species diversity, but it helps nutrients move from the surface of the ocean down to the bottom of the ocean. So this Deal vertical migration is actually really, really crucial in a lot of the daily habits of these animals and helping them to get nutrient cycling and going into different areas. So speaking of plankton, we actually have something very special for you guys today. We actually were able to bring some plankton over to you guys to meet today. Now, I'm going to go ahead and exit out of our PowerPoint really quickly, and we're going to try and transition to, we're going to stop sharing. There we go. So we're going to go ahead and try and transition out of that and bring it up to you guys. Grab the airstone. There we go. So we're going to see if it shows up right over here. There we go. So in this container, what we have over here is a bunch of brine shrimp. Now, brine shrimp are a type of zooplankton that we use to feed all of our animals. And it's an interesting zooplankton because we can grow it here at Georgia Aquarium. I'm going to set this down and see if we can switch over to our microscope camera. And give me 1 second to switch it to the microscope camera real quick and see if we can pick it up. Let me turn off the background real quick. That might be why we're not seeing it. There we go. A little bit closer. It might be a little bit tricky to see. All right, we're trying just holding up to the computer camera again, so I think it's having a bit of a hard time. Oh, there we go. There we go. Try that now. And then bring it back out a little bit. That.
Aaron, try to back out a little bit more because it's coming up blurry.
Yeah, we're trying to. We do appreciate y'all's patience. This is our first time using this. It's a new equipment we just got in. All right, we're gonna switch to our computer camera and see if we can just hold it up to the computer camera then. All right, here we go. We're gonna just try and hold it up because it looks like that Microsoft camera had a little bit of struggle, but all these little pink dots that are in here, these are all individual baby brine shrimp. And we grow these brine shrimp as animal food because it's a zooplankton and zooplankton's getting that ocean ecosystem started again. So that's what's going on over here is that we've got all these guys. We do grow them on site here at Georgia Aquarium. And what's really cool about brine shrimp is that one of the reasons that they're really easy to grow is because they do something very, very interesting. So what they do is that they live in these really dry desert climates and they live in these really salty brine lakes. And these lakes are temporary. So when they dry up, these brine shrimp switch to an egg-laying stage. And these eggs can actually survive out of the water for up to 20 years. And once they're reintroduced to water, that actually triggers their hatching sequence. So because brine shrimp eggs can do this, That's how we're able to store these eggs for years at a time and constantly have a supply of fresh brine shrimp that we can grow and hatch out and eventually feed out to our animals. So that's going to be our brine shrimp, but we also brought a couple of other cool things for you guys to see today. We brought a couple other cool things for you guys to see today. And so we're going to bring out some of the biofacts that we've got over here. All right, here we go. So one of the biofacts we brought for you guys is this is actually an experimental tracking device that we designed. So we mentioned earlier how we were using some of our manta rays to kind of test out different tracking devices. Well, this is one of those prototypes. So a lot of tracking devices in the past, they have a big needle on them to be injected into the animal's skin. This one works a little bit differently. This one actually suctions onto the skin of the animal instead, so it's a lot less invasive. And after a year or so, this will fall off and float back to the surface so scientists can collect that data and figure out where that animal has been traveling. So that's just one of the cool things we brought for you guys today. We also brought a little sample of coral. Now, coral, a lot of people mistakenly believe it to be either a plant or a rock, but it actually is a living animal. And this right here is a coral skeleton. I'm going to hold it a little bit closer to our webcam, and you see all the little holes that are on the skeleton? That's where the individual coral polyps would live. The polyp is going to be the actual animal itself. So coral is a colonial organism. That means that it's actually hundreds of animals living and working together to build one big colony. And they have to build this skeleton together out of a mineral called calcium carbonate, also known as limestone. And this is how they're going to fix themselves to rocks. Corals are a really important epipelagic zone or sunlight zone animal because 25% of known species depend on this coral in order to survive. That they need is a home or to provide food and shelter for it. So coral is really, really important. It's really important that we protect our coral. Another thing we have to show you guys, Chinmay was talking to you guys about this earlier, but this is the shell from a chamber nautilus, that cephalopod that she was talking about. So right about here is where the eyes would sit, and here's where the arms would sit. So you can really see that patterning over here. And it's kind of hard to see. I'm going to try and angle so you can see inside the shell of it as well. But past that wall in the back, that's where the gas chambers would be. And that's where that nautilus is going to let itself to kind of use its buoyancy to kind of naturally float in the water. And by controlling how much gas is in those chambers, it can actually go up and down in the water and change directions. And then one last thing we have for you guys over here. So we talked a little about deep sea volcanoes, but this is a model of what a deep sea volcano might look like, also known as a hydrothermal vent. And so some of the animals that we talked about, like the isopods, the black sea devil, the snailfish, they depend on these volcanic vents, because what these volcanic vents do is they spew a lot of chemicals out into the water, and a lot of bacteria really need those chemicals. They go through something called chemosynthesis. It's kind of like photosynthesis in plants, but instead of using sunlight, because there's no sun down there, they're using the chemicals from the volcano itself. And so animals have realized they can feed on that bacteria instead. And you have all these ecosystems just kind of hang out around these underwater vents. So you'll see these in the bottom of the Mariana Trench, kind of like how you would see where a lot of these snailfish are. So if you've ever kind of seen videos of a hydrothermal vent before, this is kind of what we're talking about. So I'm going to go ahead and bring our presentation back up. We're going to go ahead and bring that presentation back up for you guys really quickly, because we just want to cover one more thing. There we go. So we just want to wrap up real quick. So one thing that's really important to note is that all these zones that we've been talking about today, they all do depend on each other, from the sunlit epipelagic zone to that cold, dark hadopelagic zone. Now, we talked about the brine shrimp and plankton, but one thing that's really important is that what happens to the surface affects the deep ocean, because when that plankton completes its life cycle, it's going to sink back down. And a lot of those animals get their ecosystem started by feeding on that no longer living plankton that's sinking down to the bottom. So what happens at the surface does impact what's going on at the bottom of the ocean. And like I mentioned earlier with that plastic pollution, unfortunately, we have found plastic pollution in the deepest part of the ocean. We found it in the bottom of the Mariana Trench, 36,000 feet below the surface of the ocean. So it's really, really vital that we do what we can to protect this as much as possible, because people don't realize that their everyday actions, such as not paying attention to how you're disposing your trash, can in fact get into our waterways here in Georgia, which carry it all throughout the state and along to our coastlines, and currents carry it into the ocean, and eventually it sinks back down. that's where it ends up. It doesn't just disappear when we throw these things away. It does impact these living things that you wouldn't really normally be thinking about. So we hope you guys enjoy what we had to talk to you about today. So do we have any questions? All right, so do we have any questions in for us? I know this chat I saw earlier was popping off during the presentation.
Aaron, I do have a question for you while everybody is thinking.
Okay.
In terms of your career, right? In terms of how you got to this role, talk like what sparked the interest, or what classes that you took before that kind of sparked the interest to get you where you at. We're now working with the Georgia Aquarium.
Sure, yeah. So I've kind of always been, as I describe it, an animal nerd. I've always been interested in marine life and prehistoric life and all that kind of stuff. And, that's kind of stayed with me my entire life. When I was in college, a lot of colleges have an internship requirement. We have to go and do an internship at a different facility. So I end up interning at the Philadelphia Zoo in the summer between my junior and senior year of college, and I decided I wanted to do that instead of doing research. I had been helping out with some entomology research, studying insects, and decided that that wasn't for me. The zoo thing was way more exciting. After I graduated college, I went back for more volunteer positions, and as I like to say, the zoo realized I wasn't going to go away and that they had to start paying me. So I was at the Philly Zoo for a few years, and then I decided I wanted to try dip my hand into the animal care side of things. And so I was actually a zookeeper for a few months at the El Paso Zoo in Texas, working in their South American aviary with a lot of South American birds. And I was also working with a kind of wildcat called an ocelot, which looks like a very small jaguar. And that was a lot of fun, but I did miss the education side of things and talking to people about these animals and having them learn cool things. So I ended up going over to Zoo Atlanta to work education there. And then I wanted to dip my toe into the aquatic side of things because my background was very terrestrial, so a lot of land living animals. And I ended up at Georgia Aquarium working for their education department. And did you want to hear from Chinmay as well? I can
Yes.
pull her real quick.
Same
Yeah, come on.
question.
Yeah. They want to hear from you too.
Hi.
Good morning, Shamnaya. So same question for you. So what courses that you took in school that kind of got you interested into working with the Georgia Aquarium, to being with the with your career?
So I went to school for sustainability. So my degree is a Bachelor's of Science in Sustainability. So my main focus was on the environment, ecosystems, things like that. I ended up doing a internship with a company that kind of focused on like AI and corporate ESG stuff. And I realized that I really wanted to go more into the ecosystem part of my degree. And I did some volunteer work at Piedmont Park, and some more environmental stuff with Live Nation. And then I applied to the Georgia Aquarium, and now I'm here.
That is amazing. Aaron, it's so funny you mentioned the Philadelphia Zoo, because I used to live in Philadelphia. So I think they are like one of the oldest zoo there now, and it's an amazing place.
Yeah, it is. It is, in fact, the oldest public zoo in the country. For a little bit of historical context for everyone watching, hundreds of years ago, you used to have what were called menageries. This was a lot of wealthy aristocrats would have their own private collections of animals, and Europe kind of got the ball rolling by starting to open those menageries up to the public, and those were some of the first zoos, and we saw that in Europe. Philadelphia Zoo was the first one in the US to actually be a fully dedicated zoo open to the public from inception. So it is the first true zoo in the United States. So it's a very old facility. They've been around for a long time. A lot of the big animal care firsts have been achieved by Philly Zoo.
Yes. So we got a couple questions in the chat for you. One of them is, and if Chamaya want to come on screen at the same time, it says, "What is your least favorite animal in the aquarium?"
Oh, I don't think I've gotten that before.
I don't have a least favorite animal. I think that they are all unique and that they all bring their own strengths. An ecosystem is made up of several different parts, just kind of like your body, how you have so many different components working together and they're all important. And that's kind of the same way I feel about animals. I think that despite their size or what they may look like, they all contribute something really important. So I don't have a least favorite animal.
I
Wait, Shania, you can't be running away. Stay there. We got
Oh,
more
I'm so sorry.
questions.
Sorry.
Go
yeah.
ahead, Aaron.
I do agree with Jemai there. I will say though that I personally am more of a reptile, amphibian, invertebrate person. That's kind of where my interest is.
Mhm.
Not that other species are bad or not interesting. It's just not where my personal interest lies.
Okay. I got another question. Deborah asks, is anglerfish harmful and what does it eat?
Okay. Anglerfish are actually not harmful to people. I know a lot of the deep sea species, especially, can look pretty intimidating, but when you're that down the bottom of the ocean, think of it this way: looks don't exactly matter. They're not harmful to people. That black sea devil that we were talking about earlier, it's actually about the size of a baseball. It's
Mhm.
not a very big animal, and they're generally not really interested in people. It's another reason why seeing it that close to the surface was a very big deal, because it's normally one of those midnight zone, twilight zone, abyss zone animals that just kind of hangs out down there, and we don't really see it. So that's why it was making such a big deal. But yeah, it's not harmful. And as for what it eats, pretty much any smaller animal that it can get its mouth around. A lot of anglerfish do have an adaptation where they can actually expand their stomach outwards to swallow very, very big prey that might be bigger than they are. But even that has limits. Even a little anglerfish the size of a baseball couldn't swallow a person. Its stomach just can't expand that far. But no, anglerfish are not harmful. They're kind of just eating smaller animals. That's their only real interest.
Still on the subject of the anglerfish, so another follow-up question from Deborah is that it had its mouth open and she wanted to know, is that a habit?
Ooh, that's a fantastic question. In a lot of these deep sea animals, you see this interesting thing where the teeth are actually too big for them to close their mouth. And the reason why it's like that is because the mouth is sort of like I think it's like a bear trap. Have you ever seen a bear trap like in cartoons or stuff? How it's kind of meant to snap shut on something?
Mhm.
That's what they're trying to do. The teeth are kind of like I think it's like a cage. They're trying to stop the prey from being able to escape. And having lots of long, pointy teeth are really good at doing that and really good at helping you bite down and grab on the prey. Ooh, could you grab the snake model real quick? This would be a really good comparison. Yeah, so this, to show you guys, get an idea of what we're talking about. So this is a model of a snake, which is not an anglerfish, but similar idea. We get these really long, curved teeth that point backwards because we're trying to hold on to the food. So because snakes don't have arms, that's what they're trying to do. And it's the same thing with anglerfish. They don't have arms either, so they're trying to use their mouth and their teeth to really hold on their prey.
Another interesting like terrestrial comparison would be like a Venus flytrap. It also has like those pointy kind of leaves and it also traps its prey.
That is amazing, I love going to the Georgia Aquarium because I'm always amazed by the size of the space, and then to see the animals and to wonder, like, what do they eat, what do they see when they see people watching them behind the glass, what exactly is going through their mind. So another question for you. This is about chambered nautiluses, and if I mispronounce it, that just means I need to go back to school. And they said that the person didn't know that they're still alive. So is it extinct? What's your thoughts on that?
So the really, really cool thing about chambered nautiluses is that they have survived all of like the 5 great mass extinctions on Earth. They are approaching being endangered, slash they are on a watch list because a lot of people want to harvest them for their shells to make jewelry or trade it or
Wow.
whatever, because it does have a very pretty shell. But they are still alive, they do still exist, and they do live in the ocean.
How many are at the aquarium? Do you guys have?
We do not have any chambered nautiluses, and a lot of aquariums won't carry them actually because of the conditions that they need to survive, and also the fact that they actually reach maturity at a much later age than a lot of other animals. And they also, so consequently, they don't reproduce until a later age. So that also contributes to them, us seeing less numbers of them in the ocean.
Mhm.
So it's really important to continue to just try to help them where they are in their natural habitat.
And
That's
if I
pretty
could just
good.
add one thing to that answer too,
Mhm.
you do see a couple of aquariums that do have them, but aquariums that do have them are able to easily access chambered nautiluses. So, for example, Monterey Bay Aquarium in California, they're right next to an underwater trench right off the coast of that aquarium, and it's also the aquarium itself is on the coastline, so they're able to access those deep sea animals pretty easily. But Georgia Aquarium, we're kind of a landlocked aquarium, so unfortunately, it's harder for us to get a hold of them. But Chinmai is right when she says that like access to those animals is a big hurdle for a lot of facilities. So unfortunately, you might, if you do see one in the aquarium, it's very lucky. It's a very lucky thing to see them. But
Mhm.
yeah, that's why we don't have them, unfortunately.
Okay, then I have a question for you from Sarah. She asked, how do you tell the difference between the manta rays and stingrays, and do they live in the Pacific Ocean? I'm not sure if that question came from Lucas, but I'm not sure if Lucas is referring to the chamber nautiluses or the follow-up question from Sarah. But go ahead.
Gotcha. So we'll tackle the manta ray and stingray one first. So
Mhm.
manta rays are going to be very, very big, and they do not possess those venomous barbs on the base of their tail. So if it has that kind of really massive size, and the real trick is looking for those cephalic lobes, those two fins on the corner of each mouth, that's how you know it's a manta ray, and it won't have those stingers because they're using their really big size as their defense mechanism. They don't really need that big stinger. There is a smaller, closely related species that we call the lesser devil ray, also known as mobula rays. They don't have the stinger either. They look like little tiny manta rays, basically. When I first started here, I also thought they were baby manta rays, but they quickly turned out to not be the case. But most other rays are probably going to fall in that stingray category. There are a few species called guitar fish and sawfish that look a lot like sharks, but they do fall into the ray family, and they also don't have those stingers. So rays come in a lot more shapes and sizes than people think. Come in a lot
Okay,
more.
and what about if they live in the Pacific Ocean?
Yeah, they do. There are quite a few Pacific Ocean species, quite a few Atlantic Ocean species. Manta rays specifically are actually highly migratory, so you will find them following those warm water currents where the plankton are on, traveling between ocean to ocean.
Okay, since we're talking about STEM Day as well as technology, we've heard about AI. So I'm curious to know how, if you guys can tell me, or that you know of, how does the Georgia Aquarium uses STEM to support marine conservation efforts?
That's a great one. I'm gonna bring out our little tracking device again.
Uh-huh.
Do you have some info for this question? Or?
I was just gonna say, within our department, the education department, we do use AI and other tech kind of stuff to help us make sure that we are creating the most comprehensive lesson plans that we possibly can.
Mhm.
And the aquarium itself uses, while we do have restrictions, we're not just, handing everything over to tech or anything like that. We do have quite a few restrictions because we want to make sure that we are also like giving you being the public the most accurate and up-to-date information as possible, that's also scientifically accurate. Yeah, we do use quite a bit of STEM both in our department and as aquarium, in the aquarium as a whole. And Erin actually will show you a really great example of how we do in one of our research examples, actually.
Yeah, I think the lighting's not super great, even with the background. There we
I
go.
see it. Right. Hold it
There we
on.
go. If I
Hold
stand
it
in
right
front
there.
of
There
it,
you go. Right there.
if I stand behind it, there we go. We can see it. So this is another example of, a little too far. There we go.
Mhm.
So this is another example of how we're using STEM. So this was actually 3D printed at Georgia Aquarium. Our research and conservation team has been really trying to switch gears to designing their own tech for their specific purposes, and they'll use 3D printers to really create and design this. Our department, education, also has 3D printers. So, for example, Chinmai's got the model of the hydrothermal vent. That was something that we actually created within our own department with our own 3D printers. For the AI component specifically, I can say that our department hasn't really made much use of AI. We have gotten authorization though to start using tools such as ChatGPT to help us with writing lesson plans. But the caveat to that is that we have to we can use it only in certain ways. So, for example, if we're having difficulty phrasing something, trying to find the right phrasing for something, we're allowed to use in that case. But there's pretty clear guidelines on when we can use it, when we can't use it. So we couldn't use it, for example, to write the content itself. We can use it to help us phrase and articulate the content, but that's kind of the extent there. We can also use the AI in Canva. I'm not sure if our students have heard of Canva, but it's that website that lets you do all kinds of graphic design, like PowerPoint presentations, slides, that kind of thing. And we've been given permission to use the AI components there to help generate images and that kind of thing. So we do use it here and there, but it is still a very new technology in the world in general, and it's because that is still a very new technology for us. So there's lots of little ways that's subtly being incorporated, but it's kind of on the track, I would say, to being incorporated more and more.
Okay, one last question for you. Since again we're talking about students and in terms of their interests, do you know of any hands-on STEM activities or programs that are available for students at the Georgia Aquarium that you could share with them? Summer is coming, parents, and because we have some students that are homeschooled, so parents may be interested in some of the programs in terms of STEM related that may have some type of STEM related that can help them for the summer that they can get involved with.
So the Georgia Aquarium has a summer camp that our department education kind of runs. So we do a couple of different kind of concepts and courses. We have 3 separate ones for June and 3 separate ones for July. And they are separated by grade band, so that the kids will be with their peers, and also it will be age appropriate. On top of that, if you're a little bit older, like in high school, we do have some programs where you can kind of shadow some of the members of the aquarium. And we also do have internships if you're about to graduate high school or anything like that. I believe that the internships are 18 plus, but some of our programs are 16 plus, I believe. So those are some examples of stuff that the aquarium has.
Yeah,
Go
for the
ahead.
yeah, I was gonna say for the 16 plus one, that's our BELT program, which I believe stands for Beginning Environmental Leadership. Yeah, so that's
Okay.
one that's a volunteer program. So students can already sign up for that one.
That is amazing. And if you want, would love for you if you could drop your contact information in the chat as well, or how folks can get in touch with you. And then one last question, because I want to make sure Penelope has been graciously waiting to have her question answered. She wanted to know how big exactly are chambered nautiluses, and also what are their diet?
Okay. They can. You want me to tackle that one, or do you want to?
Sure.
Okay. So for example, this one over here that we've got, that's a there we go. Thanks, Jemai. That's a pretty small size one. I've seen some that get to be pretty big, about the size of both of Chinmai's hands, actually. So this is a smaller one. They can get pretty decently sized. But yeah, they're not a very, very big animal, though. They're generally on the smaller end. As for what eats them, I imagine it would be a lot of.
So it's a lot of animals that have really strong jaws or beaks, like sea turtles or like sharks. Their shell is actually pretty tough, so they have to be able to crush down onto it.
That is great. Well, we are at time. Again, Chamnaya, Aaron, thank you so much for being part of our STEM day. And I'm sure if you want to stick around for a few more minutes, and I'm sure there's some more questions that are popping up in the chat, we appreciate you. Thank you so much. I've learned something. I did not know a stingray has the, what is it? Wait, I wrote my notes. I want to make sure. Not stingray, manta rays weighs 3,000 pounds, okay? And have a wings of 20 feet. And then chamber nautilus that have 90 arms. I need to borrow at least 2 of those so I can do other stuff. Because if they got 90, I don't think they need to use all 90. I could use at least 2 more. So I learned something today, and I hope you students watching that you also learned something today. Again, please, a great big applause to both Jamnaya and Aaron. Thank you so much, you guys.
Yeah, you're welcome, guys.